In this video, I am going to find the surface area generated by rotating a parametric curve. In our case, the parametric curve is defined by x is equal to 2 plus cosine of t and y is equal to 1 minus sine of t. We rotate this parametric curve through a 90-degree angle, meaning that t ranges between 0 and pi over 2. Now the surface area generated by rotating a parametric curve is given by S is equal to integral a to b 2 pi times y ds. Now what is ds? ds is nothing but the square root of dx over dt whole square plus dy over dt whole square dt. Now the problem is very straightforward. What I'm going to do, I'm going to find the dx over dt, square it, dy over dt, square it, and then plug those values into the ds formula and then plug it back to the integral there. So given my x, dx over dt is going to be derivative of x with respect to t, derivative of 2 is 0 with respect to t, and derivative of cosine of t with respect to t is negative sine of t. And similarly, dy over dt is going to be derivative of 1 minus sine of t, which is going to be negative cosine of t. Now I could go ahead and plug it into this. So that's going to give me ds is equal to square root of negative sine of t whole square, which is sine square of t, plus cosine square of t. Negative cosine of t whole square is cosine square of t, which is just going to give me 1 dt. So ds is actually nothing but dt. Now I'm going to take this and plug it right in here. So s is equal to integral a to b. A is 0, the lower limit. B is pi over 2. So 0 to pi over 2. 2 pi times y. Now my y is 1 minus sine of t. 1 minus sine of t. Now ds is dt, so I'll just put dt. Now 2 pi is a constant, so I could pull it outside the integral. Integral 0 to pi over 2 times 1 minus sine of t dt. Now if I integrate it, I'm going to get 2 pi times t. Integral of sine of t is negative cosine of t. Negative and negative is going to make it positive. So plus cosine of t integrated between 0 and pi over, evaluated between 0 and pi over 2. So let's go ahead and do it. 2 pi times t is pi over 2 minus 0, so I don't worry about it, plus cosine of pi over 2 minus cosine of 0. Now I can simplify it further to 2 pi times pi over 2 plus cosine of pi over 2 is, by the way, 0, minus cosine of 0 is actually 1. So that's going to give me 2 pi times pi over 2 minus 2 pi. That's going to give me pi square minus 2 pi. So my surface area generated by rotating this parametric curve represented by x and y through a 90-degree angle gives me an area of pi square minus 2 pi, or I could simplify it a little further, pi times pi minus 2. I hope that this discussion was helpful. Thank you very much.